Good morning, all. And I want to thank everybody for staying put in our class training for the Ethusiast. It has really been an interesting one. And I know we've learned, and I personally have also grown in learning too, because most of the questions you ask and how you contribute to our labs has been so tremendous. So today, I promised that we're going to share our ELB, Elastic Load Balancer, which is one of the lab we did last week, Saturday. So as the custom is, sharing that live class is always long, and sometimes we may not be able to complete it because of network issues and that issue. So we always create time to do offline lab just to summarize what we've done. So I'm going to start by sharing my screen now. Yes. Okay. So load balancer, as we all know, is no more, is also like other API in Amazon Web Service. So load balancer is not new to the network or the application user or solution architect or DevOps teams or even software developers, software engineers. So load balancer has been there. It's a form of a networking thing. It always helps to secure. So what is a load balancer? A load balancer is a link that connects, that receive and share. Its own is for you to have, you can connect, is like a bridge. Instead of it to connect directly to a system, you use it to share the traffic that is coming from a certain location to the end user, to the two available resources you want to connect to. Let's, for instance, you have instances, you have two virtual machines, and you want to connect to that virtual machines because you know that there's so much load. Load in IT refers to usage, refers to requests. That's what load is. You know, in different field, load means many things. But in IT, most especially in networking, most especially in the cloud, load refers to the access, the demand of a resources. So if we have more people demanding for that resources, it's called high load. And if we have little people demanding for that resource, we call it low load or no load or average load. You understand? So it's based on that load that you're going to use to configure the kind of way your resources to be available. So the amount of demand that require from a resources, understand me, the bandwidth, everything. So in order to channel it so that some resources will not be overused, so we can cluster that resources, meaning we can do that resources to have like 2 or 3, 4, 5 form of a redundance of a particular resources, then you put something that will help share the load to those resources. And that thing that you put in between to share the load of resources is called a load balancer. In AWS, it's called elastic load balancer. Why is it called elastic? Because it has the capacity to, you can design it in a way that even the load can continue to multiply. Elastic is not stable, it's not static, it can be dragged. You know, when they say something is elastic, means something can increase and something can compress. So the elastic means that, for example, we are using a auto scaling in one of those resources. So those resources can multiply when the load is high, and can also reduce when the load is slow. So that process of expanding and reducing is called elastic. That's why it's called elastic load, which is the access to the resources balancer. So it's balancing between the load. So that is what elastic load balancer is. What you use elastic load balancer for? One, you use it to improve availability, meaning you want the resources to be available every time. Let's, for instance, we have 5 instances that is running, and they are running the same thing. You understand me? So instead of, for example, when there's an issue with a system, if you are connecting directly to a server and that server is down, you know what it means. It means that that resource is not available. But with the help of a load balancer, you can connect 3 servers with identical application to it. So when one server goes down, the remaining 2 servers takes over the responsibility as if nothing happened. So it makes that load more available. then increases fault tolerance, with that, because when there's what is fault tolerance? Fault tolerance means for a system to keep working even when there's fault. And so as I mentioned earlier, when two systems are connected to 3 servers, one goes down and 2 is up. So it means there's fault, which means one of the system is down, which is a fault. But for it to still keep working, and it means that the system can tolerate fault. That's meaning of increases fault tolerance. It provides security. Now there are some load balancer that can listen to private VPC instead of you connecting to, we mentioned bursting host, which is part of security. Load balance also increase security. You understand? It depends on, for example, load balancer can redirect an instance that is connected to a load balancer, and that instance may be in public subnet. That instance can also be a bursting host connected to another internet, another security, another instances that is in private subnet, which you cannot access from the internet. And apart from that, you can also protect the load balancer with DNS, which should be connected to WAF. You understand me? So increased security means that you cannot just attack one system and the system totally goes down. You understand? The other system will take over. You understand? So there are so many things load balancer do. And you also support HTTPS, which is an encrypted way of sending file end to end. So it increases security, then improves profitability. If you are in business and your system goes down, it costs a lot. When it is, for example, for a telecom company to go down for 1 minute, for even 1 minute, you can lose up to ₦1 million. You understand me? So if the application that you needed to be accessed is not available, so profit goes down. So increases profitability. I'm talking about that for the business people. Then it produces system resilience, makes system to be more rugged. And you get me? Then it provides flexibility. You can decide to short, you can decide to bring it down, you can decide to mix it the way you want. You can decide to design your load balancer based on the way you want it. You can say, okay, the load balancer should listen to IP. And you can say, no, don't want you to listen to IP. I want you to listen to a certain application in those applications. I will get back to that. So increases makes flexibility. You can be flexible about it, and it makes internet routing easy. So meaning you can connect to the internet very easy. You can link, for example, a web server that has a very interesting load balancer. So the instead of you 5 people trying to connect to a server makes it track. It can even increase what we call latency. It can increase, can be leads to drag. It can make system to be out. But with the help of a load balancer, you'll be able to balance the load, set the load to different. So no web server will be overstressed. You understand me? It makes you accessing it easy, and it also makes it more available. So this is an example of the main function of a load balancer is to help manage and control flow of inbound requests destined to a group of targets. As I mentioned, load, that's inbound request is called load. You understand me? Target is what you have attached to the back. So as you can see on my screen, we have a certain load balancer. This is a load balancer that is connected to this an instance. This is a Lambda. This is a compute instance. This is an application. So you can decide to design your load balancer how you want it. You understand? Then this target could be EC2 instance, range of IP addresses, even containers. Like you see, these ones are containers. This is some there's a Lambda, and this is a compute instance. The target defined within the element could be suitable across different availability zone and all places within the same single AZ. Availability zone, we know, I've mentioned in our former classes, you see what is an availability zone, what is availability domain. Next time, what is so most times there's a region. You understand? There's a region which is a particular geographic location of the way they design it in a way that, for example, we have one region covering the whole Africa, which is South Africa. So inside that region, there is like a different location, data center spread in different location. You they'll cluster it to be organized to be called a region. And that region, has some availability zone. You can group in availability zones. Most times on VPCs is AZ oriented. It's not most like a region. So you have to understand this. So you can place it in different region. You can put one in availability zone. You can put one in A1, A1B, 1C, 1D. All these one have different instances. With a load balancer, you can still spread your load across this availability zone and without having any issue. It's a typical elastic load balancer. Okay, we have three type of elastic load balancer in AWS. If some of us are familiar with, we have the internet elastic load balancer, we have the IP configured elastic load balancer, we have the application load balancer, we have the whole school, which is called classic load balancer. So basically, we have two load balancer. We have one that is old but is still supported. So what is application load balancer? What is IP load balancer? I will just go straight to the point. An application load balancer means that you have designed your load. Are you getting me? With an application on them. So you've designed your load balancer that when a certain application is being called, are you getting me? Send this request to this server. For example, let's assume this EC2 here is having HTML web application, which support Apache, which support NGX. So you can design this load balancer to listen to end that any requesting for http.html.index.html should send it to this. Right, this one could be PHP index.php, send it to this, or a certain application, depends on the kind of application you have. So you configure the application, the load balancer, to listen to a particular request relating to that certain application. Why IP configured load balancer is load balancer that immediately requests come in, are you getting me? You can spread it to all load balancer without specifically looking out for the application. So which is round robin most times uses. So immediately requests come, is spread it to the IP and share. Most times it makes the system more relaxed, more available. The load balancer is easier because it's not trying to look for application to see, okay, this is the application. Is this application in this server? Is this in this server? Okay, send the request, spread it. So most times, most networking, you use IP configured load balancer. But for our training today, I'm going to focus on application load balancer, which is in different level, things in level 7, while IP is level 4. So for some of us that are into the layers of IP, talking the first one, which talking about the normal binary code, you're talking about the second layer, which talking about your system MAC address and that stuff, and go down to TCP and all that stuff. So load balancer is in the highest, which is level 7. Level 7, I don't know, it's in level 4. So that is it. So this is an example of elastic load balancer. So as I mentioned, this is what makes it elastic, the auto scaling, so the request coming in maybe through S53, which means the DNS, maybe like osatoame.com.ng or gemoworld.com.ng. There's DNS request to, okay, I want to connect to HTTP Apache server straight to this place. So when the load is increasing, you can design it that, oh, please, when the load gets to like 50% for 5 minutes, get on that instance. So this is another interesting function why people take cloud very importantly, because it can increase the servers and reduce it. This is what makes it elastic. So these are the things we need to configure a load balancer. You need the elastic load balancer. You need to configure the security settings. So configure the security group. You configure the route table, the routing, then the target which you are going to have, meaning the load that the the instances, the resources that the people requesting for it wants to connect to, which are the core targets, and you review. Then after review, then you launch. So these are the things you need. We are going to make use of VPC, which is we have mentioned before, virtual private network, at least 2 subnets. Load balancer work with at least 2 subnets. Interestingly, you can even, I think there was one configuration I did. I used one instance, I put the 2 instances in the subnets. So there's a way you can also do it, but most times it's always advisable to have 2 different instances in different subnets. And so because load balancer, you must have A and B, it's a must. Then you have the route table, which we know, target group, which I mentioned, listener, meaning what is going to be requesting to, what is going to be connected to. And they were going to talk about internet listening to port 80 or port 443. They're talking about the internet gateway. We're using that gateway. Then we use auto scaling group. Then this is our architecture today. This architecture was connected from AWS. So it's available at AWS. So you can take a screenshot of this. You can also go to the site and just click and absorb it. And so look at we're talking about many users. So I only put one user here, many users using their own system. Maybe one user using the system, and the system is connected to the internet, which is HTTP or HTTPS. Then it's connected, it's trying to, so from there is linking to the ELB. You understand me? The ELB, which is elastic load balancer. The elastic load balancer, automatically transfer the load that is coming from the request to either of the instance. And so this one is we now, the students, the engineers, the infrastructure engineer, the DevOps team, the networking team that is in charge of configuring the load balancer. So using the API CLI, which we are going to use, like I think our CLI today will making use of PuTTY. You understand me? Then this is the owner, the IAM. You must have an IAM configured to that user to have the capacity to launch the load balancer. So I'm going to make use of an admin IAM rule. Then this is our console, which means what we're going to use to connect to the AWS environment. In this case, we are using single sign-in console. We're going to use normal web console. Then the DNS talking about configuring it to, instead of directly using the IP address to link, we're going to convert our IP address or our URL from the load balancer to a name. So I want to make use of DNS Route 53. Then it's optional, but this is our training today. Then another interesting thing that a load balancer do that I want to also mention is that it helps you to check all the instances at the back end, the targets, and see if they are working well. If they are not working well, we tell you the health check is not working well. But there are sometimes you can also, maybe there are some servers that you don't want, that you want to work on. It will be working. You can manually configure it and say, okay, just say this server is not working well, so that the load balancer will not send requests to it. You can configure that. That will be in advanced class. You can configure that. So it can also happen. So that is it. This is our lab. So I believe with this, our little presentation before we go into our lab, you're able to understand load balancer. So in our next slide, we're going to focus on the lab itself. So I hope it comes handy. Thank you so much. So let's move to our next class.